So thanks, Howard, and over to you.
Paul, thank you very much, and thanks. We've also got people from Germany. Well, excellent, guys. It's lovely to have you here. It's always a privilege to talk to you. And today was one of those that I don't know why we always seem to get to data storage last, but it's one of those really exciting areas that I've spent most of my life. I think I started my career off as a DBA. And certainly one of the things that I see when we teach data storage and operation, it's all about the production DBA and the developer DBA and all the different people around. So yeah, storage is an interesting one, and I must admit, I do believe that this is one of these areas that is growing, like metadata, it's growing extremely fast. I don't know how many of you guys are up to date with the latest sayings. I know Kobus is here and he probably is up to date with all the latest technologies. I wonder how many people have heard of a data mesh, a data lake house. I mean, we've all heard of a data lake, but what is a data lake house and what is a data mesh? How many people are understanding what it means? And I almost felt sorry for those people that have to manage this environment, because it's becoming, it's growing so quickly and growing so fast. And how do we understand the requirements and find architecture? So it's a combination of data architecture, but also of architecture in terms of finding how do we store our data properly. Now, and it's not just as simple as, oh, let's move to the cloud, because we do know that even on the cloud, there's so many different options. So you could take the easy way out. You could go to the cloud and really just have your SQL Server or your Windows Server installed there. And from there, you can go all the way to what's referred to as a data mesh. And Esther, you're right, it's not a movie Lakehouse. It's actually that combination of a data warehouse and a data lake. Okay, so for all those and I think we learn, and I will start to explain the differences between data lakes and data warehouses, but it was some of the challenges that you faced with the data lake, and then how do you combine that with the data warehouse? So always the good news for me is that we're not throwing away any of the stuff that we've learned in the past. All the BI, the data warehousing, the data marts are still there, but we have to make these worlds coexist and bring them together. Okay, so let's see. The essential concepts are going to be pretty long on this one, and then we will have a brief discussion on the strategy for data management. But let's see how it goes. And guys, if you, I did find it hard, actually. I found it hard to have a clear and simple explanation of what these different areas were. So please stop me and ask lots of questions. I know Paul does, except when it's on the ontology side, right? then it's not so. Okay, cool. Let me move on. Okay, so this is what we. Just to check, everyone can see my screen. It is visible to you, eh? Okay. No one's saying anything. Excellent. All right, so essential concepts. And this is going to be this combination of the essential concepts in the DMBOK and then how I have things moved along. So helpful to get a clear understanding of this. Interestingly enough, a few people have asked us in the last week or so to explain this asset versus base. And initially, my first answer was it's got to do with transaction processing. But then we do understand that base doesn't have transactions, so it's not really transaction processing, it's more database processing. Okay. And as part of that, we have either we go into an asset type of scenario that we've lived with most of our lives. That was in the 1980s, where we created these transactional databases. And then we brought in base, and that was to increase the volumes and the variability of data. So sort of data that it was pretty hard to put a transaction boundary around a massive document, and was it really necessary in terms of making changes to each word? Were you going to go into a transaction boundary? Now,
Can you explain what a transaction is?
Yeah. And so a transaction, so let's describe a little bit about a transaction, and let's to do that, I'm going to focus on the asset side. And that stands for autonomicity, consistency, isolation, and durability. So what our focus is if we update and our updates is changing multiple tables. Okay, so let's say we've got a whole lot of new customer details. For example, Howard arrives in Riyadh, and I've got a visa, and I've got all my personal details. I've got my ID card and things like that. And we then do an update, and it updates not just my name table and my ID table, it's updating a whole lot of other areas as well. So the idea of autonomicity is that it's either all works or nothing works. So either part of all my my details in my profile have been captured, or there are no details about me. And then we have consistency, that the transaction must meet the rules at all times. So when we do data modeling and we build foreign keys and we build check constraints and everything like that, we need to ensure that at the end of the update or the insert or even the delete, that the transaction meets all of those rules that have been put into our data model, right? And to keep the database consistent. So we can't, for example, have one table that's updated and it has a foreign key to another table, and the foreign key information in this table that I've been updated doesn't adhere to the constraints of the other table. So we have to make sure that everything's consistent. Isolation means that the transaction that I'm working on is isolated from all other transactions. So no other transaction can impact me, and that's typically where we could fall into this problem of deadlocks. So if we're both trying to update the same thing at different times, or maybe different tables, and we're both locking each other out, we can put the database into a deadlock, and then just about nobody can do anything on the tables. Even a select, unless you have a with no lock, your select is going to hang as well. And durability then is the situation of once I've updated, then it cannot be undone. Unless, of course, we have a restore from a database and we roll forward the transactions, and then it could be undone that way. But typically, it can't be undone. So that was the world of relational and transactional, and then we came into this base scenario that's basically available. It's soft. There's a soft state, so it's constantly changing, and we have eventual consistency. And probably the one that I always quote, the easiest to explain this one, is something like our cryptocurrency or Bitcoin, our federated database, our distributed ledger. When I add a block onto the chain, for a blockchain, not every element in the network has that block on the chain, on the chain that they have. And at some stage, they will all have that block on the chain, and the data eventually becomes consistent through all of the distributed nodes. So the idea was that we are going to improve our level of data availability by distributing the nodes and allowing them to operate independently. So if one node goes down, it doesn't really matter. We can have availability on the other side. So we also must pay attention here that, yes, within a relational database or transactional database, I can build these always-on systems, fault tolerant, and have mirroring and replication. But this doesn't ensure that the transaction is updated in all places and everyone sees the latest. It doesn't demand that, so it doesn't have those tight processing requirements. And I always provide the example of, if I have a bank account, I should use ACID so that if I either withdraw money or I deposit money, I can see it. If I go to another machine down the road, I can see that that update has happened on my account. Whereas that's not always appropriate in a document management system or even in cryptocurrency. We don't always demand that level of consistency across all of the distributed areas. And this also ties into the DQ dimension of consistency. Okay. All right. So just to check, I wasn't checking that there were any questions. So let's move on a little bit. So these are also implications. I liked this slide. And there were a few things that came out to me, especially on the base side. I've always understood ACID. That's for me, it's always been simple and because I suppose I've lived with that sort of transaction system most of the time, and it's consistency first. Whereas base is availability first. So they'll much rather have that the system is always up and responding to the customer rather than having consistency of data across all the nodes. And the other interesting one was last write wins. A lot of the times this is managed by the developer. And of course, we're scaling out on unlimited number of nodes, and ACID tends to scale up with limited number of nodes. Of course, when we go into the cloud, that sort of changes, and we don't really know how many nodes that's going to. And we are seeing that some of the big drivers for Hadoop and the massive HDFS systems are being challenged somewhat back to that ACID type of scenario. And it was interesting to see some of the challenges that Hadoop as a company was experiencing. So this is another description of the differences between ACID and base, the implications. And then this is more formal, the one from Damer, the DMBOK, and I like this as well. Notice, for example, ACID, the schema must exist. We must have a data model there, whereas within base, that data model could be changing all the time. So we have the schema must exist, the table structure must exist, all the table rules must exist, the table type, the column data must be typed, whereas on base, we can be dynamic, we can adjust on the fly. The document that we're using can have an extra node or attribute added to this element of the document, and it can store dissimilar data, so it's not forced to be consistent data. Consistent, strong, consistent, available, and base. They can be strong. You can force it into a strong consistency mode, and one also realizes that the base area is saying when I need transaction boundaries and transaction, I can ask for it. But other than that, you'd be probably sitting on eventual, and in some cases, you can be sitting on none, where you're not interested in ensuring consistency across all the nodes. You're really just interested in keeping some of the nodes up to date with the information you require, but not all. And that's some interesting things when we start to see the data mesh that comes along there. So Esty, I see you have a question. Is EDW normally using base? Yes. And this is sort of what we came about where the data lakehouse came along. That was sort of Emmeline, sorry, and Esty as well. So the data lakehouse, the data lake is base, and your data warehouse is ACID. And so sorry, so the EDW is normally ACID. Sorry, I got that wrong. EDW is normally ACID. That's transactional. When you do any updates or inserts within that will be up to date, and the EDW will be consistent. Okay. Whereas ACID is typically sitting in the lake, and it can be adjusted, and it can store dissimilar data. So, Emmeline, did that answer your question? So EDW relational databases, they tend to be a relational structure, enterprise data warehouse, and when you create a lakehouse, you're actually merging the lake and the warehouse together to have both ACID and base existing in a similar environment. So Esty, your question, when would you need to decide what processing you're going to do, asset versus base? Or could you have an architecture that these parts are for asset and others are for base? So the answer is yes. A Lakehouse actually supports both. And Esty, you would choose an asset when you really need consistency. So for example, my bank account and my bank balance, I need consistency. If I'm constantly withdrawing money, we need to know at some stage that I've got to zero, and I can't keep going, depending on my account, of course, but I can't keep going below zero.
Would something that doesn't need consistency be something like, I don't know, the reviews that got added to a movie, for example, like where there's not really, there's not implications if it's a bit late?
Yes, correct. No one's going to scream, for example, if I don't see that update immediately.
Yes. Okay, cool.
It doesn't impact. So it's almost you don't have a scarce resource that you're trying to protect. And we got into some fantastic discussions yesterday when we said bank account, everyone could agree, and then I mentioned plane tickets or seats on a plane, and then everyone said, yeah, but the airlines are overbooking them, they're double booking them. But what they typically do is that before you actually get on the plane and you're at the boarding counter, then they'll ensure that only one person can sit on that seat. But they do oversell those tickets and overcommit the tickets. But generally, at the end of the day, it's only one person can sit in a seat. Sorry?
That's the Americans.
Yeah. No, but I think all airplane companies are doing that. And that's typically because they do have an understanding that certain people are not going to arrive. I know I nearly missed my flight on the way onto Riyadh. If it wasn't for Paul holding the counter open, I don't think I would have got there. So they do understand that maybe 5%, 10% are not going to attend. That means their flight is empty, and so if they go to that next level, then they're hoping that they can get 100% on that. Yeah, so asset is required for OLTP. Now, this is also interesting, Mark, because you can get some of that strong in an OLTP, depending on the type of processing that you take. So it's sometimes debatable as to whether you need that. All right, so let's go on. So let's go back to this one, and just to clearly understand, we have those architecture types: centralized, distributed, but not federated, and federated. And centralized would almost represent that of an old mainframe. Once upon a time, we only had one location. Those were the easy days where I didn't have more than one database. And there are several systems or companies that still operate like that. And that means that the one database is fine, and if it goes down, it's not a train smash, and you can still operate like that. And then after a while, and that may be due to performance or requiring availability, you can start to distribute. And notice that you would, here in this scenario, you've got 3 locations. The users actually don't know that those locations are different. And I was very fascinated the first time I installed the mirror, wondering how the application was going to deal with it. And there's a special setting in the connection string to be able to say, if I have a mirror, the connection within the .NET framework or whatever it was would automatically reconnect to the mirror on the other side. So if A went down for whatever reason, we were mirroring. That meant that C became the principal, and my queries automatically would go to C, and the application wouldn't notice that it was down. Okay, so we achieved this with mirroring. That was the best one, where you have nothing. Replication, you could have synchronous or asynchronous, and depending on what level you were interested in terms of your availability. Replication was also used for performance issues on reporting. So they would take all the reporting issues off the OLTP, and typically you could write your reports with a select only, so there were no updates, and you were just reading the data. So if we could, for example, get all of the reading off database A and onto database B, we would reduce the load across the two. And there we would have a replicated node, which was reporting. Okay. All right. Now we have a federated scenario where we are completely separated. They are not copied. So the data in A is not copied into the data in B. And a simple example of that would be some level of disk partitioning. And you could have, for example, all the data in Saudi sitting in location A, and the data in South Africa sitting in location B, and the data in Canada sitting in location C, and then maybe they didn't have anything for Scotland. They could bring that on later on. And then there would be a view that when you issued the query, SQL understood, and I'm using SQL Server as an example because I've set this up before. You actually told SQL which disk to go to get what data. And if you said select star from DMBOK training where location is equal to Riyadh, it goes to location A. It doesn't even issue the query to location B and C. So if you've got billions of records, all the records don't come into memory whilst it's trying to resolve that. It just partitions the data and goes to the appropriate disk, and it picks it up from location A. Now, we had different, we even within Federated, we have different approaches. The users they could actually hardwire the views, and there we can see the view would know that it's got these separate locations. And then we've got a loosely coupled where it's independent, and we could just keep on adding locations and our views would keep on working. I've also done this a lot with data warehousing, where you have incremental loads, and each location represents a different day in the load period, and then the view goes across all of those areas. Okay, all right. Now, what's important here, and I've got these a little bit mixed up, but I'd like to start off with this the CAP theorem, which is important, and what it's telling us is that we have two options. We can choose two, and the rest and the third one we compromise on. So the CAP theorem talks about pick two. So I either want partition tolerance and availability, and then I'll need to deal with inconsistent data. And in this scenario, I'd need to have a base type of approach to dealing with that. Or I can pick consistency and partition tolerance, and then I'm not always available. Or I can pick consistency and availability, and then we can have we can't allow any system failures. Okay, so the larger the distributed system, the lower the compliance to ACID. So that's sort of going back, SD, in terms of trying to explain which ones you would choose when you're requiring more and more distribution. And just to have a quick example, that's something like the blockchain, where any one of these nodes could be down and the system still works, the less I can enforce the ACID approach. Okay. Now, and so the CAP theorem says any two of the following properties can exist in a shared system. Now what we found is that this used to be the case, and we always used to battle that we had no way around it. But notice what this Lambda architecture has done. And the Lambda architecture almost allows us to have all of them. We've got a speed layer, which doesn't always have a consistency. And then we have a batch layer that has that ACID type of approach. And the nice thing about that is the source data comes in, it gets split into the speed layer, so for immediate viewing, whereas the batch layer, it can take some time before it gets processed and added to history. But the serving layer then helps us pick the data from the right place, either serving or batch layer. Okay. Okay. Yeah, Mark, you're right there. So it's like good, fast, or cheap. And there's the other one is the PMBOK, or the project management. This is sort of the area that Paul Bolton spends a lot of time on. So you have those three constraints. So it's either the cost, time, or quality. And what I like to say to some of the customers is, you choose two and I'll choose the third one. So if you want low cost and low time, then I'm going to give you low quality. Okay, and so we have a similar type of situation here. Okay, so that's the blockchain, and what we see here, just a simple, it's very federated. There's no central server. So every single one of these nodes are independent. There's no one person that's in charge of anything. If one node goes down, then the other nodes pick up. So to go through that on a simple scenario, A wants to send money to B. They create a transaction, which is represented as a block. This is transfer money A to B. That block is broadcast to every party in the network. Again, every party that's available. And it gets approved by 2 or 3 of the miners, or 2 or 3 of the people, and once it's been approved and that you've been verified, it adds that block to the chain. So notice that's where it comes on along as blockchain. And once this has been added, then the money gets sent to B. And the important thing about this chain is that it's immutable, meaning that once it's been added, you can't unadd it, you can't undo it, and you can't update it. And it's similar to what they have the idea in a data lake, is data that has been added to a lake cannot be updated. And so we've got some interesting challenges with that we need to pay attention to.
And each of the miners has a copy.
Each of the miners has a copy, but the copy may be out of date. So
But that's why it's federated.
That's correct. Yeah. Hopefully you guys are picking that question up. So Veronica asked, are each of the miners up to date? Those miners that were notified and took part in that transaction, they are up to date immediately. But for example, if these two weren't there and weren't listening at that point in time, or weren't part of the transaction, they would not have that block on their chain. They would eventually get that block onto their chain. They'd eventually get it into the right level, but not immediately. So the consistency is not there across those federated databases. Okay, so this is sort of what's happening to our progression that we're doing. The data warehouse, that was the late 1980s. Notice that we had operational data and some level of external data. This is an amazing company doing some amazing stuff called Databricks. I got this article from there. They do the ETL. It either goes into an enterprise data warehouse, EDW, or a set of data marts, and from there we have the reporting. Okay, and I think this is almost Kimball's definition of multiple data marts make up a warehouse, whereas Inmon would say I have an EDW, an enterprise data warehouse, and then I have smaller marts off that. And then notice the lake. What the lake's doing is we're adding data to the lake, all the different types of data, but then we go through a massive preparation outside of the lake to almost virtualize the data, do some level of ETL, be it in memory or be it processing, and we go into the data marts or a real-time database, and we have the reports coming off that. Or if we're doing some level of analytical analysis, we'll go through the data prep validation, and then we've got data science and machine learning on the other side. Now, look how interesting this Lakehouse is getting, where it's a lot of the processing has now moved almost into that combination of lake and warehouse. And then we're getting reporting going off the edge of that. So can you see that that sort of processing has moved into that node? And we get, so just one step further. So here we've got our Lakehouse. So we've almost built a data warehouse and a data lake together. Some of that processing has been brought together. Of course, be it batch or streaming with a Lambda architecture, be it structured or unstructured. The unstructured data will typically live in your lake, but it can also have structured. And then we have this integration between the two areas, creating our Lakehouse. Now, the way it actually operates is that it has a indexing and caching layer and a catalog, and that's I'm sure many like 4 or 5 years ago, everyone was shouting about data lakes, and within 6 months to a year, that data lake became our data swamp. And then the next year, everyone was shouting about data catalogs and how we had to make sure that we understood all of the stuff in the lake before it became a swamp. And now this Lakehouse is taken a level further, where not only are they understanding all the data there, but they're also having some of that ETL and analytical processing and caching and indexing and on top of documents and unstructured data, so that our level of analysis, our visualization level, the BI, data science and machine learning, can work off that layer over there. I suppose I'm just going to pause for a little bit just to see if anyone has a question around that. Everyone seems very quiet, but are we seeing this combination, this world coming together of data warehouse and data lake? Are there any questions?
And like Databricks is just a service provider that does the data lakehouse. Like you can choose a data lake architecture or person that does that and a data warehouse, and that's kind of how you combine those two to get that.
Yes, and
you'll find an indexing layer.
Yeah, and you'll actually find that Amazon and Google and all of and Microsoft, they're all supporting this. Even Azure has a data mesh and a data lakehouse. So they
data mesh a different word for data lakehouse almost.
No, I'm getting to that one as well.
Okay.
So I think it's the Databricks that came up with the idea of being able to add and take away that processing that was happening outside of the lake, and then almost combine the requirement of ACID and base into one area and not have that level of separation where you have to still move stuff out into the warehouse.
I see what you mean.
Yeah. Okay, so Emmeline is asking, data lakehouse is new to me. I think I actually asked Veronica if she could help me this morning on with some of all these new terms, and she said, but I don't know any of these anyway either. And yes, I think it's new to a lot of us. We see Bill Inman getting into lots of the discussions of how you can join all of this information together in one layer. So here we can see, Emmeline, that there we have the data lake, and then any form of moving from a lake that's typically in a base format, getting it into an ACID format and getting it that structure. So the lake was basically the no schema, the NoSQL type of structure. There was no schema on it, and therefore it didn't ensure transactions or quality in certain elements. And we were desperate to get that into our warehouse where we got the business rules and consistency enforced. That's now come into the data lake house and allowing us to give good quality data on the areas that we needed, and then certain base areas in that on the area that we don't need it. So we've almost brought these two worlds together to live together to give the consistent data when we need it, depending on your type of analytics, in your warehouse to get everything together, and then data that doesn't always need consistency as well as available. Okay.
So is is something like Snowflake, is that a native lakehouse? Because
yes,
is that
there's also they have some interesting ingestion as well, Paul, which they call the snow plow, and then it lands up into the Snowflake. And then what you will find is that Snowflake has got all those different ways of interacting with data, both on your base and your ACID approach.
Okay, so it can actually handle either style.
Yes.
Facet and base. Okay.
Yeah, and I've actually there was an actual. I thought I had a diagram here.
I see Mark's comment there. If I remember correctly, I think it's that's a good way to think about it. But I think the Snowflake product was developed by some ex-Microsoft guys, some ex-SQL Server guys.
Yeah. And I think what sorry, Mark, would you like to?
I'm not certain. I know there's some ex-Oracle guys there too. Maybe they got together in the bar and said, "Hey, let's write this time."
Yeah.
Let's join forces.
We were looking at it at my last client, and then COVID hit, and that project got parked. And now we're building a lakehouse. So this is very prescient, very current at my current client. We're trying, and that's why I say the devil's in the details. These architecture slides that we've got here are great. I use them too. We've bought in hook line. We've bet the farm on Microsoft and Azure and Databricks. And yeah, there's cool stuff. Databricks, you can just point it at your data and it'll sample it and figure it out, the schema. It'll assign data types, but it samples a portion of the rows. It can't read the entire data set.
Yeah.
So there's still lots of opportunity for tuning.
Yep.
It's cool. I'm happy to be having the opportunity to work on it, but it's giving me some gray hair as well. It's not as easy as the vendor would have you think.
Yeah. Look, I was actually called by a customer that had gone to that Parquet format to almost that blob format for BI. And they were having some serious challenges in terms of their latency and being able to get it back into that structured format that a warehouse works with, that people are so comfortable with.
Well, and it's one thing to flatten out. So the analogy I use is we're taking an orange and we're flattening it out, like we're compressing it, getting the juice, the pulp, the pith, the skin into the lake, and then we have to reconstitute it back into an orange so that we can report on it from Power BI.
Yeah, we can actually get it almost into that virtual data format, that rectangular format again.
Yeah, it's cool, but the engineers, the pipeline engineers are pushing back on the complexity of trying to implement ACID-y kinds of things. Like we're taking all the referential integrity out at the source as we land things in these various landing pipelines into our raw lake, and then we're trying to reconstitute it
back on the other side.
On the other side, like this, messy to tidy that we've talked about, that you guys like to do, right? Getting it tidy again.
It's a nightmare.
It's work.
And that's the sort of features. And I like that you bring in a good point there. And this is what they were saying here, Mark, is to say the Lakehouse is adding features to the data lake. Notice data mutation. Hopefully you guys can read, but I thought it was a very important set of notes. So the data lakes are often built on Hadoop or AWS, HDFS. This means the data cannot be corrected. With this also comes the problem of schema evolution. And there are two approaches here, copy on write or merge on read. And you sort of bringing this back together in a data virtual environment or in your data warehouse, where you're bringing that back to life again and you're sort of getting the format right. So you're squashing it into an orange and then you're bringing it back into, It's almost like, I remember working with the object management group on Corba, and that you go through with an object in a persistent framework. So you materialize it and then you dematerialize and you materialize. So to get the data out of the object or the class, you dematerialize it, put it into the database as a blob, and then rematerialize it back on the other side when you need it. So nice. So here are the challenges that a lake suffers with, and this was amazing to me just to realize the limitations of that lake. The ACID stuff is not happening within there. Time travel, so you don't get time travel on a lake. Almost remember that last writer wins. If not, then you create another instance of the record. So that's where you bring in, for example, change data capture on the mainframes. So as an element is changed on the mainframes, it would write a change document away, and then it kept on writing change documents because the last writer wins, and you can overwrite what you did. And then it's also introducing data quality. Now you can only do that, a lot of that powerful data quality, when you have your schema enforced, so you can bring the rules back together. But it also allows us to work with independent on our format, and then it supports the batch and streaming, the real-time thing. So it's got the Lambda architecture. It's now reintroducing the data warehouse structures in that, hence called the data lakehouse. Yeah, and schema drift, that's almost sort of where you have the documents and a JSON document, and you keep on adding to it. Then what happens? What format am I dealing with? But I really like the latest SQL implementation called Polybase, and our ability really just to deal with what we know. And yes, the schema can change, but tomorrow when we understand that thing that's changed, we can add those extra elements back into the warehouse when we need them. Paul, I'm not sure if that's answered your question. Okay. All right. So let's try to get to the mesh. These are the features. Now we then moved on to the mesh, and there was a really nice article done by ThoughtWorks and Martin Fowler. I'm always amazed that I think at the moment he's Mr. Microservices and domain development. And he was the one that we picked up on the patterns right in the beginning in the 90s. We started looking at his work, and he's getting involved in a lot of this domain packaging, and he does that with microservices as well. And the whole idea about microservices is, and I'll try to get to an example. Here's an example of microservices where each domain operates in the way that they want to operate. And in reading some of the articles, that domain, there's almost a team of developers by domain. They choose their warehouse structure, they choose their data products, they choose whether they want ACID or base, they choose which database system they want. But they then there to support all of it. And then there's this communication between the different domains and the different data products that are part of that domain. So we're bringing together a whole lot of infrastructure and technology. We covering this infrastructure and technology by presenting data products and the different domains. And then these domains can be introduced, and they can be correlating data from other domains. And then there's this global governance and open standards. And this was a sample of the harmonized mesh that Azure presents. And notice they've got all of the governance templates in the middle, and then nodes can be instantiated, but they adhere to the governance and the controls defined by that hub. And each node can provide a specific data domain and their own set of data products. So here we can see whether this is a level of data virtualization, or what level of integration we're doing between the different areas. This is how they put together that harmonized mesh. And then to simplify it, it took me quite a while to have that understanding, is allowing almost a data lake and a data lake house that was forced into one area to be federated. So now we can have multiple data lake warehouses all over the different areas, all over the world. We don't need to worry too much about getting that into one environment. And so we've got this scenario where the data mesh is connecting the different silos. And the silos are quite intense, because you could have completely different infrastructure and technologies that implement a silo or a data domain. And it's getting around all of these things with having consistent access control, connectivity, and different governance that they apply. Okay, so the mesh has really just almost taken that data lakehouse concept and then split it up into data domains with data products, and said now we can all live independently, we can all choose our own infrastructure. Of course, a lot of these companies these days are providing multi-cloud solutions and hybrid and on-site. So that's the sort of situation that we're seeing, where we're breaking everything up and we don't need to get everything consolidated again. Okay, I then wanted to just touch on this edge computing, just to give you an understanding of what it means. Is what we're trying to do, we brought everything together into these centralized data centers, and that in itself created some inefficiencies with the application from a bandwidth and a throughput perspective. And so what Edge is doing is actually moving these nodes and decentralizing the traditional data centers and getting them closer to the end users. So you'd almost have a edge processing center in each of your big towns in the different countries that you're operating on. And the first time I heard that happening was when they were developing or choosing locations for data centers. And I saw a paper on an area in Germany where they actually gutted an entire building that was sitting next to the stock market, and they created a data center right next to the stock market, so that it had zero latency in terms of putting trades into the German stock market, compared to others that would have some level of latency, and they would get on the scene later than this massive data center right next to the German stock market. And the interesting thing was that when we looked at some of the stuff, they were even suggesting that some of the areas were in the ocean. And of course, we're seeing Microsoft putting some of its cloud into the ocean, into the different areas. Of course, that's probably to deal with heat and other aspects, but they've mapped out the entire world, and they put these edge computing areas all over the world to improve this bandwidth and throughput. Okay. Yeah, Mark, I mean, your mesh, when you start bringing that together, and Martin Fowler is big on that canonical model, where your microservices have a well-defined canonical model. And of course, your EDW is a source of that canonical model, and that overall model or ontology of everything that's working. Yeah, so you're going to have those controls coming through. All right, so that was just one hectic understanding of what's happening to our distributed and federated databases. When we go down to the organization, these are the three typically controlled structures that we have. Hierarchical was in the mainframe, where everything was a tree structure. That was the first database I worked on, Adabas Natural, hierarchical trees. And then DB2 came along and created this relational, which was schema on write. And that's when we started with a proper, almost the intense data modeling, third normal form, so help me God. And then after a while, people started battling with that. They started trying to put massive fat documents into a relational table that never worked. And we then moved into this non-relational data lake schema on read approach. So you'll notice here that this is very much a less controlled structure. And when we move to the other direction, it's more controlled. So you've got like a taxonomy structure in the hierarchical area, and then you've got zero structure on your left and right, and you can read in any different formats. And of course, the different types of document databases, we have a document, a graph, key value, and column, depending on how you wanted to set that up. Okay, so a long story to then get to where our data manager gets involved. They are having to understand this plan for business continuity. and Esti, I know that's what the manager has to have these discussions, almost that pick two thing with his users. You can have two, but I have to choose the third one. And same with project management. So the data manager needs to understand the requirements and plan for business continuity. And I was fascinated. Again, you keep on learning each time you go through the DMBOK. There's almost one driver for data storage and operations, and that is business continuity. Okay, and the database manager needs to ensure that we get that business continuity. So this is what deliverables the manager needs to create. He would almost suggest that there's certain evaluation criteria that the technology and the actual database, the database technology and the database deployment, that it meets that criteria. And of course, it meets his levels of business continuity plan. So those are the areas that the data manager needs to get involved with. Okay, so if we now sort of come back to the data manager and the role that he plays, and coming back to what is storage management, it's the software and processes that improve performance and of data storage resources, not just performance, but also the ability to prevent data loss, your DLP, and to meet data retention requirements and to reduce IT expenses. So these are all the sort of processes that need to be established to achieve this. Okay, that's where his focus is. And what are the important elements on a data storage management strategy? Ensuring you got the secure data, meeting the compliance. I'm not sure how many of you know all the challenges. For example, if you in HIPAA, how many requirements there are on your data management system. That was a nice learning curve for me when I had to set up a database management system to adhere to HIPAA. There were all sorts of flags that I had to set to ensure the database always got rid of the data that was sitting on the disk before the database came along and took that extent. That was nice to learn about that. And our apps, our performing apps, the better user experience of that, certainly on all the querying and things like that. Ongoing availability and reliability, lower costs, more efficient operations, resource utilization. So, I mean, that's really fantastic now when we see with the cloud how we can spin up certain nodes, compute nodes, do the processing, for example, on a data mart, shut them down, and only use them when you need to. And all of this can be controlled programmatically. We've got more flexibility to be able to bring together both that availability, consistency, and always scalable. So where is the future of data storage? And I'm sure you guys have seen now that this thing is moving so fast. I liked some of these comments to say that cloud storage was trending before the pandemic, before COVID, and has skyrocketed since. And basically, once organizations go into the cloud, they typically stay there. But there is an element that we're seeing with, I'm just trying to see if I've got it, sorry. There's an element that we're seeing with this multi-cloud and hybrid approach where people are saying they're wasting too much money on cloud implementations for certain applications. So they are now trying to find the right place for these different areas and to get them set up correctly. So to make the best use of AWS and Azure and your local storage for local applications. And these are the different, from when you go into the cloud, these are the areas that you have to look from a management point of view, automation and orchestration in terms of how the data is coming in, migration of applications, images, virtual images, configuration management, security, of course, you can't ignore that. And I think, Paul, there was a good discussion yesterday about cloud, where yes, the vendors are doing a certain amount of your security, but there's still a lot more for you to take care of. They don't say that we've done everything. They can't, for example, automatically add encrypting and hashing and obfuscation on certain fields that are personally sensitive, or SPI, or even PCI. They can't just automatically do that. You have to take some care of that. Governance and compliance across all the different threats, I think that's very valuable, where they can handle that facility approach. But again, we know from data security that everybody's involved in getting the right level of access control. Performance monitoring and hosting, there's some fantastic features and functionality that we now have available to us in terms of monitoring the performance, and cost management, which is massive for cloud. That thing scales tremendously. And I certainly know Paul and I have almost just gone through a process with a company that had expanded into the cloud. They had overexpanded, and when they looked again, the costs were dangerously high, and they had to do something to get it back together again. Okay, sorry, I went a bit over time. Are there any questions, any comments?
I was just going to write in the chat window, Howard. I agree. I mean, I think when my CEO at my client gets his invoice next April, maybe next September from Microsoft for our Azure, he's going to be asking some tough questions.
Yeah.
I'm already seeing it. They're clamping down. I mean, they implemented something called a cloud business office where you could submit a ticket. I want to move my on-prem thing to the cloud, you know, to get resource groups and storage containers and stuff created. And they're already pushing back. They're asking a lot more questions now than they were months ago. Because never mind the data swamp, getting naming wrong. I mean, one of the things that our client did was they decided everything had to have 3-letter abbreviations. That's fine. So you get these resource names, STO-EDW-ADF-SBX- this 21 character string of 3-letter acronyms strung because you have to have unique names in the cloud too. Guess what? It's not magic. If you have 4 hard drives plugged into your PC, you have a C drive, a D drive, an E drive, and an F drive, right? Moving all this stuff to the cloud, moving hundreds of servers worth and, you know, dozens of databases worth of stuff to the cloud, you got to get a naming strategy together. And a bill, again, I think the bill is going to be, next year, the billing is going to be silly.
Yeah, we had a guy working with us who's on the call here. ST would have known him. Well, how about you? You would too. Let's just say his name starts with a W and his surname with a G. But we had as a company, we were encouraged to play on AWS because we were becoming partners with him, and we needed to learn. But in a matter of minutes, he just created pretty much a whole call center worth of machinery, and it cost us a lot of thousands of rands, which AWS was kind enough to return to us and say, okay, we understand you were sort of just trying things out, you didn't know enough, so you know we can sort of help you out there. But yeah, I mean, these things can be very quickly okay. And even for one of our clients at the moment, we had to help him choose. I mean, we're not talking big, we're talking a very simple database requirements. One database, SQL Server, nothing fancy. But just the cost for, and this is a startup, you know, small company, just for the difference of going, okay, well, do I take a hosted instance, a hosted Azure SQL instance, or do I go with a VM? Now, just that is a massive price difference from a small company perspective, right? And then when you go VM, it's about, all right, well, do I go with the Linux or Windows? Do I go with a spot instance or a always available instance, or, you know, all those kind of things? And literally for the same database, and for this customer, they didn't even know needed the database to be up all the time. Only when the Power BI file is refreshed. So it's literally from maybe 150 rands to 10,000 rand a month. That's how, okay, in dollars, I can't quite calculate right now, but I mean the difference is quite big.
Yeah.
And just a little bit of a not knowing enough, or there's a couple of small things that if you do it wrong, the cost is going to explode very easily. I presume Howard, knowing in that hotel that he's at, I don't know if he's on still, but
I'm back. Yeah.
we tell that hotel Wi-Fi reset. I don't know how it happens, but it just happens once an hour at least.
Yeah. I think they probably have some sort of storage or throughput, and then after a while they just kind of.
Well,
Yeah.
there are definitely throttling parameters for network switches. Right? And after a call has lasted, right, they'll guarantee you a quality of service for the first hour and then reduce your quality of service the second hour and so on. So that the kiddywinks playing their streaming games don't overtake the telephone network.
Kiddywinks, yeah.
Howard, you mentioned the security thing. I posted the link there. Amazon, they've got this well-architected framework.
Yeah.
There's 5 pillars to it, and the one pillar is security. It's actually worthwhile mentioning the others as well. It's talking about cost, because cost optimization is one of the pillars.
Yeah.
So they put these things into a matrix. So operational excellence, security, reliability, performance, and cost optimization. You go in they've got nice courses around this stuff as well. So if you become solution architect, you have to have all those things bedded down. But the security one is interesting because they make very clear, this is what we are super responsible for from a security perspective, and these other things is your responsibility.
Yeah, I suppose they have to, because you can go in there thinking they're going to deal with everything.
Yeah. But it makes sense. I think by and large, it's probably more secure than many of our on-premise database or systems.
Except the one that I lock in my safe.
Yes, who did we talk to? Actually, it was one of the girls in my class. Yeah, it was. There's a department there that their computer systems are not connected at all to the.
I've seen that.
Yeah. So if they've got a sort of a different set of computers if they have to communicate with the outside world, but they just keep it locked up.
Yep.
That's the way most process control networks work as well, right? They're firewalled off. There's a air gap. There's a demilitarized zone between the process control LAN and the business LAN. We've had to set up SQL Server replicators. We've got them running on-prem to on-prem, on-prem to cloud now.
Yeah.
Just to get the data out. We want the process data and we want to get it into our warehouse.
Yeah.
We can't allow a business LAN user to write a query against. In some cases, it's a performance issue, right? It's security for sure. We don't want a packet from Calgary getting up to the mine, right, potentially infecting a mine system. This is 7/24/365, and there's a real-time component because we've automated a lot of the stuff in the mine. There's autonomous haul trucks. These things are all automated, and they rely on the computer dispatch system to be there, telling them what to do next. So we can't issue a long-running query to the SQL server that's supporting the dispatch system. That's not allowed.
Sure. Yeah. Well. Yeah, Paul and I went down to Session, and they told us, Mark, how when they do have a truck that goes into repair or just to maintenance, and they bring it back online, and they have to run it around the system for quite some time without any load on, just to relearn the layout. And they were explaining how they reintroduced the trucks into the platform again, and that was quite fascinating.
Interesting.
Great. Any other questions, Mr. Bolton? Can I hand over to you?
I have one more question.
Yes.
Where are you dining tonight in Tiala Street?
Oh no, we're going to that place that Sammy took us to. Remember the sweet shop, basically.
Oh, nice.
I'll tell you now.
So have a kiss, quite something. Enjoy the pistachio.
Thanks, everybody.